So there is a force downward, or it can also be upward. Okay? Pag upward is loosening, yes, loosening up, and then downward is tightening. So the force, and then from the point of application of the force, kung nasaan yung kamay, up to doon sa pivot point, that's the moment arm. No? So we have to multiply the magnitude of the force and the perpendicular distance. So that's the moment arm, and then it will give you a moment. No? And then the effect of the force, of course, is to rotate, no? To rotate the body. Okay? So yun yung moment. So this is actually the same as the torque. Okay? Sa physics, pinag-aralan nyo to, yung tinatawag na torque. Force times the moment arm. No? Pero sa statics, we call this moment. Okay? So this is the formula. You have the moment at a certain pivot point, okay, is equal to the product of the force times the moment arm, which is the distance. Okay, so sa English units, it is pound-foot. So that means to say, pounds here refers to force. So much better if we're going to make use of a subscript F, no, to denote that it is a force. So pound force foot, or sometimes pound inch, no, in English units. So pag inches naman, nauuna yung force, pound inch. Pero pag, yes, pound foot or pound inch. Now, other books naman, foot pound. Okay, foot pound force. Okay, so pwedeng ma-interchange. And then SI, Newton meter or kilonewton meter. Okay, if the force is already or already reaches thousands, we make use of kilo. Okay. So we have this, the effect of the moment is to rotate, no? Rotation yung effect. Okay, another application is yung sa seesaw. Okay, so sa physics, ito ang pinaka-example, no? Yung balancing ng seesaw. So we have both sides, there are forces. And then the distance, itong may support at the middle, no, is what we call the pivot point, no? That's the point of rotation, no? So that is the pivot point. Okay. So we have here the two forces, i-equate nyo lang. Q times this, Q times OQ is equal to P times OP. Okay, so that's the equation to be used. Okay, the moment on the left must be equal to the moment at the right. Okay, so take note that the pivot is at the middle such that one of the forces, say Q, produces a clockwise moment. Okay, clockwise yung effect ni Q. Whereas yung P produces a counterclockwise moment. Okay? Because kapag in-apply mo yung P, it will cause the lever to rotate in a counterclockwise direction. Yung Q naman, if you're going to apply Q, the effect of Q on the lever is to rotate the lever on a clockwise direction. Okay? So in a two-dimensional case, moments may be added algebraically and a proper sign must be assigned. No? So meron na tayo na pag-agrihan ba dito? Ano ba yung napag-agrihan natin? Clockwise ba negative? Okay, and counterclockwise positive. But you can always use your own sign, no? So kung saan kayo medyo sanay, yun na yung gawin yung positive. Okay, kung sanay kayong positive sa clockwise, then make use of that. Yung iba naman, kung sanay kayo na counterclockwise yung positive moment, then so be it, no? Parehas lang naman ang ano dyan, sagot. Okay? So you just have to, from the start of the problem, you must state your sign convention, no? Na you are using or you are assuming that clockwise directions are negative moments, okay? And counterclockwise will result to positive moment. Okay, so let's have this one. A 500 Newton force is applied to the end of the lever, pivoted at point O. Okay. So find the moment of the force about point O. If, okay, letter A, the angle between the line of action of the force and the lever, which is represented by theta, is 30 degrees. Okay. Letter B, if the angle is 120 degrees. Letter C, if it is right angle. And then letter D, the angle is 50 degrees. Okay? So A and D are both acute angles, so less than 90. Letter B is an obtuse angle, 120. And letter C is a right angle. Now remember that moment can only be computed if the line of action of the force, no, is perpendicular to the distance. No? So that is the principle. Okay, the line of action of the force must always be at right angle. Okay, otherwise, o dito, letter C lang ang nagsasatisfy. Di ba? Letter C lang yung right angle. So yun lang ang nagko-comply ng sa principle. Okay? So may moment siya at letter C. Sa letter A, B, and D, meron din siyang moment, but we need to find the force that is perpendicular, okay, to the distance. No? Now, the distance here that is considered is the length of the lever. No? Yung haba ng lever. So, that distance is the segment AO. Okay? So, AO, which is 200 mm, yun yung distance. Okay? So, as you can see, in letter A, 30 degrees yung angle. So, hindi siya perpendicular. No? So, that means to say, you cannot use, no? You cannot use directly the 500 Newton to be multiplied with the 200 mm. No? So, meaning to say, you are going to resolve the force. No? Kasi 30 degrees lang siya. So, dapat baga naka-perpendicular. Okay? So, if the situation is such that the force is not perpendicular to the lever, then you need to find the component of the force. that is perpendicular to the lever. Okay? So in letter A, if the angle is 30 degrees, then you need to find, okay, the components of the 500 Newton force. Okay? So you need to get the X and Y components of the 500 Newton force. So if this is 30 degrees, and then ito yung kanyang components and this one. Diba? So that means to say, the component that is perpendicular to the lever is the opposite of the angle. Diba? Itong this one. Okay? So that is opposite. So 500 sine. Diba? 500 sine 30 times 0.2. Okay? So we need to convert this from mm to meter. Okay? So this one, okay? So 500 sine 30 times 0.2. Okay? So that is one solution. Okay? And what is that? Equal to? O 1/2, di ba? 1/2 yung sine. So times 500, so that is 250 Newton meter. Okay? So letter A is 250 Newton meter, and that is clockwise direction. Okay? So dito sa solution, if you can see, kinuha mo na yung distance. Okay? That is perpendicular to the force. So ang ginawa niya is the distance is 0.2 times cosine 60. So that is 0.1. No? So, pero itong distance na to is horizontal. Okay? So ito, moment is 500 times 0.1, so 50 Newton meter. Okay? O bakit naging 50 to? Okay. Kinuha yung distance times the force, 30. Okay, so if this is 30, so kinuha muna yung, okay, hindi kasi naka-scale. No? So if this is 30, so this, and this is 60, so this must be a right triangle. Okay? So nandito yung force, it is vertically downward. Okay, so that is correct, no? So this is vertically downward, 500 times this distance. Kasi ito yung naka-perpendicular. Okay? So that distance is 0.1. So 0.1 times 500 will give you 50 Newton meter. Okay? So 50 Newton meter. Negative because it is clockwise. So yung kanina, yung sinabi ko kanina is we get the component of the force. That is another solution also, no? Pero ang makukuha natin doon is we retain the length of the lever, 0.2. Tapos kinuha natin yung perpendicular component of the force, which is 500 sine of 30. So 0.2 is 1/5 times 500, so that is 50. Similar to this. Okay? So parehas lang ang result. Whether you retain the force, etong ginamit dito sa libro, ni-retain niya yung 500 Newton, kinuha niya yung distance na perpendicular sa line of action of the force. Another solution is maintaining the distance, which is 200 millimeter, and then you compute for the component of the force that is perpendicular to the lever. So, dalawang way ang pwedeng gamitin. Okay? So, yung pinakita dito sa libro is isa lang. Pinakita dito is yung force ni retain pero kinuha niya yung distance. Yung example ko naman kanina is ni-retain ko yung distance na 0.2 at kumuha ako ng force na naka-perpendicular sa 0.2. And that force is the component, no? Okay? The component of 500 newtons that is perpendicular to 0.2. So you're going to get the same result of 50 Newton meter. But you need to mention the direction. Gaya nito, no? Okay. So 50 Newton meter clockwise direction. Ito, no? May arrow siya ng curve tapos nandun yung arrow on a clockwise direction. Okay? So dito, ang clockwise na, ang sign convention ng author is pag clockwise, negative. Okay? So 15 Newton meter clockwise direction. Now what about if the angle is an obtuse angle greater than 90? So for example, 120. Okay? So ginamit naman dito is 0.2 sine of 60. Okay? Ito kasi yung figure. Okay? So if it is 120, then the force must look like this. Okay? Ito. At ito yung 120. Okay? So if this is the case, the force, hindi rin siya naka-perpendicular sa lever, di ba? So, ang ginawa dito is kinuha yung distance that is perpendicular to the line of action of the force so that that will now represent the moment arm. Okay? So kapag ganito, what you will do para hindi kayo malito, you simply extend the line of action of the force. So extend ito, in-extend dito to the left horizontally. Okay? And then from point O, project vertically up until it intersects the line of action of the force. So dito siya nag-90 degrees. So therefore, from point O up to that point, that is the lever arm. Okay? Now, paano nyo kukunin to? It is opposite 60, so therefore sine of 60. Okay? So the perpendicular distance must be equal to 0.2 sine of 60. Okay? 0.2 being the hypotenuse. Okay? So ito yung computation. So having found that distance, you simply multiply that with the given force. Okay? So the force was retained again. 500 pa rin, no? Times, kumuha siya ng distance na perpendicular dun sa line of action. Okay? So we have 86.6 Newton meter, also clockwise. O ano pa yung isa, yung ginamit natin kanina, i-apply nyo rin dito. What will you do with, halimbawa, gusto kong i-retain uli itong 0.2 as the lever arm. So, anong gagawin nyo sa force? Para makakuha kayo ng perpendicular. Anong gagawin nyo?
Multiply sa cosine 30 po, sir.
Okay, get the component, no? So, if this is the force, i-resolve nyo to, gawa lang kayo ng rectangle dito. Diba? Gawa kayo ng rectangle. such that the force is the hypotenuse, then ito yung kanyang component, no? Ito, itong direction na to. That is perpendicular. Okay? So how are you going to get this distance? Ito, yung if this is di ba ilalagay nyo rito, gagawa kayo ng right triangle. So itong distance na to is adjacent to this angle. So itong angle na to is x plus 90 equals 120. Di ba? Kasi obtuse to eh. So obtuse lagi ng may right angle. So 90 plus what angle? 90 plus x equals 120. So therefore, yung x is 30. Okay? So yung distance natin na hinahanap is dito, which is adjacent to 30 degrees. Okay? So therefore, yung component niya is 500 cosine ng 30. Okay? So 500 cosine 30 times 0.2. Try to compute that if it is equal also to 86.6. Paki-compute nyo nga. 500 cosine 30 times 0.2. What's the result?
Same po, sir.
Okay, the same, no? 86.60 Newton meter. Okay? So kapag ni-retain nyo yung lever arm, yung force ang gagalawin nyo. Okay? Find the component of the force that is perpendicular to the lever na 0.2. That is also another solution. Okay? The first solution was, ito yung ginawa sa book. Okay? Hindi niya ginalaw yung 500, pero humanap naman siya ng distance na perpendicular sa 500. Okay? So, it's up to you to choose kung saan mas madali sa inyo. No? Okay? Yung i-retain nyo yung 500, ang gagawin nyo lang dito is extend the line of action of the force, then from the pivot, project a line that will intersect the line of action of the force, and their intersection must be at 90 degrees. Okay? Kasi yun ang requirement. Okay? Okay. When the angle is exactly right angle, what will happen? Wala na kayong gagalawin. All you need to do is simply multiply the force times the lever arm. Kasi nagsasatisfy na to ng definition ng moment. Force times the perpendicular distance. Okay? So direct substitution. 500 times 0.2. That's it. No? Okay? So 500 times 0.2, okay, will give you 100. Okay? 0.2 is 1/5. So 1/5 of 500 is 100. Don't forget to mention the direction, no? Because moment, just like a force, is also a vector quantity. Okay? Yung 100 Newton meter is simply the magnitude. Magnitude lang yan ng moment. But since it is a vector quantity, you must always specify its direction. Dalawa lang naman yun. Clockwise or counter. Okay? Okay, what if the angle is back again to an acute angle? No? So parehas lang to nung, di ba 30 degrees kanina? O ito 50, parehas sila acute. Okay? O tingnan nyo kung paano kinocompute yung perpendicular distance. Kung i-retain nyo yung force, hanap kayo ng distance na naka-perpendicular sa line of action of the force. O tingnan nyo ginawa dito, no? In-extend downward to the right yung line of action ng force. Okay? And then, from the pivot O, nag-project sila ng line that is perpendicular to the line of action of the force. 90 degrees. Oh, no? So, yung intersection na yon, connect that with the pivot point, that is already the lever arm. Okay? So, the problem here is how to find the distance, no? So, alam nyo naman na this is right triangle, Pythagorean. Okay? So, distance is opposite 50, sine function ang gagamitin. So, 0.2 sine 50. Okay? So, this is the result. Then, this distance must now be multiplied with the given force. And that will give you 76.6 Newton meter clockwise. Okay? Or negative 76.6 Newton meter. The negative sign indicates that the direction of the moment is clockwise. Okay? Any questions so far?
Wala po,
Okay, the
sir.
meron?
Wala naman po.
Okay, so naintindihan ha? So basta importante dito yung perpendicular distance with the line of action of the force and the direction. Okay? Varigdon's theorem states that the moment of a force about any point is equal to the sum of the moments produced by the components. Okay? Okay, let's take a look at this figure. Okay, figure 2-14. Okay. So we have a force F applied at point A. Okay. So ito yung force F applied at point A. Now the force F is resolved into its x component, Fx, itong horizontal, and the vertical component, Fy. Okay. Now, if we take the moment at this point, itong pivot point, okay, O. If we take moment at O, okay, using the components, di ba, itong Fy, itong Fx, Fy. So, pag gumamit kayo ng component, okay, forget about the original force. Hindi na yung kailangan. Okay? So when you make use of the components, and these are Fx and Fy, you forget already the original force. Kasi ito na yung gagamitin nyo. No? So, dalawa na ngayon, di ba? Both of them, merong moment with respect to O. Okay, by the way, if the force, no? If the force passes through the pivot, zero moment. Okay? In all cases, no? Kapag ang force dumaan sa pivot point, wala siyang moment. Zero. Why? Because wala siyang moment arm, no? Wala siyang distance. Okay? As long as the force hindi dumadaan sa pivot, mayroon siyang moment. Okay? So dito, ito bagay yung F, i-extend niyo downward. Downward, no? Ito nga, sundan nyo lang tong galaw ng cursor ko, no? So if you extend the line of action, mag-i-intersect siya somewhere here. Sa bar, no? So, ano ba, ibaba natin yung force. Excuse me. Hello? next na natin tong force, line of action niya, downward to the left, mag-intersect siya somewhere here, di ba? To. O hindi siya nag-intersect sa O. So therefore, masasabi natin na yung force na yon merong moment. Okay? Now, how do we compute for that? Okay. Using Varignon's theorem, that the moment of the force, kung yung moment nitong single force, must be equal to the moment, sum of the moments ng component niya. Okay? So if we resolve this force, Fx and Fy, into Fx and Fy, no? Then we sum up the moments of these components. Okay? So dalawa na ngayon yung may moments, si Fx at si Fy. So si Fx, asa ng kanyang moment arm? Ito, si YA. Okay, ito ang kanyang moment arm. Kasi si YA perpendicular sa force. Diba? O ito naman si Fy, saan ang kanyang moment arm? Extend mo to dito. O, ito ang kanyang moment arm, si XA. Okay? Si XA times Fy. Kasi perpendicular. Si Fx naman times YA. Kasi perpendicular sila. Okay? Now, in setting the equation, kung ano yung sign convention nyo, unahin nyo yung positive. Di ba sign convention nyo is counterclockwise positive, right? O sino dito sa dalawa ang may effect na counterclockwise? Si Fy o si Fx? Sino? Sa dalawa ang may counterclockwise effect.
FY po, sir.
Okay, good. No? So Fy will have a counterclockwise direction. So unahin nyo yun, Fy times XA. Okay? And then, itong Fx, clockwise ang rotation with respect to the pivot. So it will give you negative moment. So the equation is now, the moment at O is equal to Fy times XA minus Fx times YA. Okay, so ito na siya. Okay? Kung bakit inuna si Fy? Because siya yung positive moment, no? So Fy times its moment arm XA minus Fx times its moment arm YA. So itong right-hand equation, ito yung summation of the moments of the components. Okay? Parehas ito ng F times the perpendicular distance. So alin ang perpendicular distance dito? So if you try to extend further pababa, ano? Ayan. O dito pa sa baba, lampas pa dito, no? So extend mo tong F pababa. Tapos lang bumaba ka pa further hanggang sa makalampas ka sa O. Okay? O, nakita niyo yung line dito, itong tinitrace ko. Yan. Saan magi-intersect siya? Ito, drop a perpendicular line. Yan, no? From O, downward to the right. Okay? So, magi-intersect siya with the line of action of the force. Itong maliit na distance na to, ito na yung moment arm. Kung gagamitin niyo yung F directly, no? Ibig sabihin, hindi niyo kukunin yung component. Pag hindi niyo kukunin yung component ng F, kukunin niyo tong maliit na distance dito. Ito. Okay? So F times this distance is equal to Fy XA minus Fx YA. So that's the Varignon's theorem. Okay, principle of transmissibility. Okay? Ang ibig sabihin nito is transferring the force to any of its along the line of action of the force, dun mo lang siya pwedeng i-transfer. Yung point of application, no? Of the force. Ang line of action niya is infinite. Okay? So pwede mo siyang i-transfer yung force kahit saan dun sa line of action niya. Okay? Until such a time that makakakuha kayo ng isang component na dumaan doon sa pivot. Okay? So let's take a look at this one. Ito na yung kaninang example ko, di ba? Na kapag binaba mo yung ito yung line of action of the force, ibababa natin, mag-intersect siya dito. Di ba? Now, pag nag-intersect na siya dito, doon mo siya i-resolve. Ito yung kanyang Fy, ito yung kanyang Fx. Okay? Now, nakikita nyo, ito na yung kanyang component, itong upward and itong horizontally to the right. Now, sa dalawang component, alin yung parang dumaan sa pivot? Alin sa dalawa? Yung if you are going to extend yung mga kani-kanilang line of action, sino sa dalawang component ang dumaan sa pivot O? Sino yung dumaan sa pivot O? Si Fy ba o si Fx?
FX po, sir.
Yes, si Fx, no? Kasi if you extend that to the left, siya yung dumaan sa O. Pero si Fy, never. Di ba? Never na si Fy dadaan sa O. So therefore, since si Fx dumaan sa O, wala siyang moment. Zero moment. Ibig sabihin, wag nyo na siyang isama sa equation. So ang may moment effect lang si Fy. Okay? And the effect of Fy to the bar is to rotate the bar counterclockwise. Diba? Gaganon yung bar counterclockwise. So the moment arm of Fy is ito. X sub B. No, this is XB. So force times the perpendicular distance. So yun yung moment. Okay? So itong moment na to is also equal to this. Okay? Pero dito kasi, ang in-apply dito is principle of transmissibility. Okay? Ibig sabihin ng transmissibility, yung point of application of the force acting on the body may be transferred or may be placed anywhere along the line of action. Di ba? Ito yung line of action niya, di ba? So kahit saan dyan na point, pwede mong ilagay yung force. Kasi kanina, di ba, nag-umpisa tayo, yung force naka-apply lang sa A. Doon lang siya naka-apply. But in effect, pwede mo siyang i-transfer kahit saan as long as nandun lang siya sa line of action niya. Okay? So itong principle of transmissibility, mula sa point A, transfer niya dito sa point B. Bakit sa point B niya transfer? Kasi kapag sa point B, ni-resolve mo yung original force, isa sa mga component dumaan sa pivot. Okay? So kapag isa sa component dumaan sa pivot, isa na lang na component ang may moment. Yun na lang ang gagamitin mo. So minus 1 ka na. Okay? Mas madali na kasi wala ka nang iisipin na eliminate mo na yung isang force. Okay? So that is transmissibility. Okay, let's take an example. Determine the moment of the 100-pound force about point B. O, ito yung pivot, point B. Okay, there is no angle given, but the slope of the force is given. Okay, will you give me the slope of the force? Cherry?
4/3 po, sir.
Okay, that's correct. No? 4/3, hindi 3/4. Okay? The slope is rise over run. Ang rise dito ay 4. Okay? And yung run is 3. So 4/3. Positive. Because the force slants to the right. Okay, so using Varignon's theorem, okay, determine the moment. Varignon's muna tayo. Yung resolve the force at point A. So this is Fy and this is Fx. Okay? So if the slope is 4/3, what is the cosine of the angle? 3/5, di ba? And sine is 4/5. So the y component counterclockwise, the x component is clockwise. Set up the equation. Okay. So using Varignon's theorem, 100, itong component niya is opposite. So sine. So sine is 4/5. Okay. So 100 times 4/5 is 80. O yun yung y component. 80 times 8. Positive, no? So 80 times 8 minus, ano yung kanyang fx? 100 cosine, 3/5. So that is 60. Di ba? So 60 times 4. Okay, so 8. Hello, excuse me. Sige, nag-lecture pa kasi ako. 10 minutes. Okay, thank you. Bye. Okay, so yung kanina, the y component is 4/5 of 180, di ba? So yun yung force na gagamitin, 80 times 8 minus yung kanina naman na x component, 3/5, 60. Di ba? 3/5 of 100 is 60. 60 times 4, 240. Kanina, 80 times 8, 640. So 640 minus 240, how much? Okay? Ginawa kasi dito transmissibility, no? So gawin muna natin yung Varignon's. So ano yung mako-compute nyo dito? So we have 4/5, 80 times 8, 640. Tama? 640. Minus, ano yung x?
60 times 4 po.
Oo. Anong difference niya?
400.
400. Sa Varignon's, yes, no? So, ito yung answer. Pero kasi dito, ginamit dito is transmissibility. Pero ako gusto ko kasing ipakita sa inyo yung dalawang diniscuss natin. Okay? So, in using Varignon's theorem, magsa-summation kayo. Summation of moment at point B is equal to 80 times 8 minus 60 times 4. Did you get it? Nakuha niyo kung bakit naging ganon? Ha? Ni-retain natin yung 8 tsaka 4 kasi yun na yung kanilang moment arm. So, ang ginalaw natin yung force. Bakit yung force ang ginalaw? Kasi hindi siya naka-perpendicular kay 8 at hindi rin siya naka-perpendicular kay 4. Kaya ginawa natin, ni-resolve natin yung 100 into its component. At doon natin nakuha yung 80 tsaka 60. Yung 80 tsaka 60, yun na yung ginamit dito sa 8 tsaka 4. Yung 100, forget about it, no? Kasi kinuha na nga natin yung or ni-resolve na nga natin siya into component. So that is varignons. Sa varignons kasi, nagsa-summation tayo, nagsa-sum up tayo, no? Now, in transmissibility, yung ginawa dito sa, what do you call that? Dito sa solution, sa book. Eto. So take a look at this, kung paano ginawa. In-extend downward yung line of action of the force. And then, nag-drop ng perpendicular line doon sa line of action kasi naka 90 degrees na dito. Now, the problem in transmissibility is magko-compute kayo ngayon ng distance. Pero, hindi nyo naman gagalawin yung 100. Okay? Hindi nyo na siya i-resolve. Ang co-computing nyo dito is yung moment arm. Okay? So, paano nyo nakukunin yung moment arm? O, ito yung ginawa dito, no? Tangent alpha. So, ginawa yung tangent alpha is 4/3. Diba? So, yun din ang ginawa kasi dito. Diba? Ito yung alpha. This is also alpha. And this is also alpha. Okay? Vertical angles. Itong alphang to, tsaka ito. Vertical angles are congruent according to geometry. Diba? So, makukuha muna dito yung alpha is 4/3. Tangent, no? So, yun ang inequate dito. CD is equal to AD over tangent alpha. Kasi yung tangent alpha is equal to AD over CD. Ito. AD over CD. Okay? Ito kasi yung alpha. Ito rin yun. Ito, AD over CD. Okay? Itong yung D na to is also equal to this AD. Okay? So, yung distance is equal to 4 feet. Okay? Kasi nga ito, parehas, no? Itong triangle na to is also equal to this. So, kung 4 feet ito 4 feet na rin. Okay? Or, kung para maliwanag, gamitin nyo yung 4/3 na tangent, no? Or that is the slope. Tapos yung BC is equal to BD minus CD. Alam nyo na yung CD, di ba? Ito yun, no? 3 feet. Okay? From tangent, kasi alam mo yung tangent ng alpha 4/3. So 4/3 is equal to 4 over x. Halimbawa, x2. Okay? So makukuha nyo yung x 3 feet. And then, since alam nyo na 8 feet ito, yung total mula dito kay B hanggang 8 feet. So 8 minus 3 is equal to 5 feet. Yung BC pa lang yun. Yung hypotenuse nitong right triangle. Now, the D is one of the legs. So, apply nyo na naman yung Pythagorean theorem. So, sine of alpha, opposite, which is D divided by BC. And that will give you 4 feet. Okay? So 4 feet times 100, direct na, wag nyo nang gagalawin yung 100 kasi nga D na lang ang kinompute natin. So that is 400 pound-foot. Okay? And the effect is, anong effect nito? Counter, di ba? Counterclockwise. Okay? Positive sign. Clockwise moment. Okay? Ito pala yung varignons kanina. Ito pala. Kala ko wala eh. Tama na yung ginawa natin kanina, di ba? 80 tsaka 60. So 80 times 8 minus 60 times 4. So, the same result if you use the varignons and then the principle of transmissibility, you are going to get the result, no? Yung isa pala direct, ito yung transmissibility. Okay, transfer nyo dito yung force along the horizontal ng bar. Ni-resolve. Pag ni-resolve mo, ganun pa rin. 80-60 pa rin siya. 80-60. Kaya lang, yung 60, siya yung dumaan sa pivot, wala na siyang moment. So ang gagawin nyo, ang may moment lang is 80 times 5. Ito lang. Yung 80 pound force times 5, yun na yun. Moment at point B. Nawala na si 60 kasi nga, pag in-extend mo yung moment arm niya, dadaan sa pivot point, which is zero moment. Okay? So using transmissibility, using Varignon's theorem, you will get the same result. Okay? Okay, next meeting we are going to continue. Okay. We continue with our lesson. Siguro we continue with the moment, konti na lang yun, and then we start with friction. So read about the new lesson, yung lesson 6. Okay? Para pagdating dito, at least alam niyo na. Okay? Any questions so far?